Welcome to GOC43 Product Training. GOC43 Training Number 2 is an introduction to GOC43 programming platform CodeZees 3.5. This is a quick start guide for developing a PLC logic and design visualization screens for HMI. Main purpose of this training session is to have basic hands-on experience of CodeZees. We will avoid detailing of features and functions. Let's see contents of this training. We will start with the GOC Toolkit version 3, which is installation setup. Subsequently, we will have a brief information about CodeZees, the application program development environment of GOC43. CodeZees is compatible with IEC 61131-3 standard. We will see project structure in IEC 61131-3. This information will help in understanding GOC43 project and its components like tasks. After that, we will launch CodeZees and create a new GOC43 project using project template. In due course, we will understand different components of GOC43 project. We will develop a simple application program to turn on LED from illuminated key using function key on device. We will also design an example visualization to show key status on display. We will download project to GOC43 and go for online monitoring. At last, we will understand source code download process. GOC Toolkit version 3 is a bundle of programming software and plugins required to program GOC43. GOC Toolkit consists of programming software CodeZees v3.5, definitions of GOC43 devices, main units and extension units, software libraries, user documents like user manuals, installation manuals, etc. Installing the latest version of GOC Toolkit v3 ensures that you have the latest version of softwares, devices, libraries and user manuals. You can download GOC Toolkit from Mitsubishi Electric India website www.mitsubishielectric.in. Now we will get introduced to our new programming platform CodeZees v3.5. CodeZees is one of the most popular PLC programming software across globe. It supports all 5 programming languages mentioned in standard IEC 61131-3. Programming languages supported by CodeZees are ladder diagram, instruction list, structured text, function block diagram, and sequential flowchart. Apart from these, CodeZees also supports additional language continuous function chart. CodeZees provides single platform for PLC and HMI development, which enables user to freely access all PLC variables in HMI application. CodeZees offers simple drag and drop approach to design visualization screens for HMI application. Before creating your first GOC43 application, let's understand concept of control application in IEC 61131 standard. Diagram shows software project model defined in the standard. At the highest level, the control application required to solve a particular control problem can be formulated as a configuration. Configuration includes common elements like hardware, memory addresses for I/O channels, global variable lists, etc. Within a configuration you can have one or more resources. You can look at a resource as a processing facility or controller that is able to execute IEC programs. Within a resource, one or more tasks can be defined. Tasks control the execution of one or more programs or function blocks. Tasks can either be executed periodically or upon the occurrence of a specific trigger. Programs can be written in any of the IEC-defined languages like ladder diagram, structured text, etc. GOC 43 project structure allows 1 configuration and resource and 3 tasks. Out of 3, 1 task is dedicated to visualization and 2 tasks can be used by PLC. By default, visualization task is of type freewheeling, that is, it will keep on executing with lowest priority. Remaining 2 periodic tasks can be used to execute user PLC program. When you create new project using GOC 43 template, 1 visualization and 1 PLC task, main task, will get added in project automatically with cycle time of PLC task equal to 50 milliseconds. It is advised to keep task properties of Visu task and main task unchanged. If you want to execute some critical functionality of PLC application faster than 50 milliseconds, you can add 1 more task in GOC 43 project. After starting CodeZees, application window will open. CodeZees will open the last saved project by default. Let's understand different components of user interface of CodeZees. Device tree. In the devices view, you organize your devices, application, programs, and visualizations. In this view, you can configure main unit, I/O extension units, COM extension unit and communication protocols. We will come back to device tree later in this presentation. Device editor window. Double-click on any device in device tree to open its device editor window. Depending on type of object, content in working window will change. For example, in case of hardware module, you can see parameter configuration, I/O mapping, IEC objects, etc. In case of POU, selected language, for example ladder editor, will open. In case of visualization, visualization editor will open. You can open multiple editors and switch between them easily. This is ladder editor. When ladder editor is open, toolbox contains elements required to develop ladder diagram. You can drag and drop ladder elements from toolbox to working area. This area shows toolbar of CodeZees. There are tools available on toolbar for project operations like open or save project. Edit tools like undo, redo, cut, copy, paste, etc. Find and replace tools. Tools to edit bookmarks, compile project. Online tools like login, logout, run or stop controller. Few toolbars are displayed only when specific editor is open. For example, when ladder editor is open, ladder toolbar is displayed. When visualization editor is open, then visualization toolbar is displayed. Menu bar commands are provided for file operations, edit operations, view operations, build operations, online operations, debug operations, etc. When you are in ladder editor, ladder menu bar is displayed. You can use ladder menu commands for editing ladder. When visualization editor is opened, visualization tools are displayed on toolbar and also visualization menu is displayed in menu bar. You can customize user interface using menu command, tools, customize. Here you can customize menu commands, toolbars, and keyboard shortcuts as per your own convenience. Now you have some basic idea of CodeZees user interface. We will see further details of user interface later in training videos dedicated for ladder editing and HMI programming. Now, we will learn how to create a new project using GOC 43 project template. GOC43 application program consists of devices, tasks, POUs, visualization screens, libraries and other components. To avoid manually adding items one by one, application is created using project template. Project template adds all application program components necessary for PLC and HMI application for GOC43. When we execute command, new project, this dialog will appear. Select projects in categories section. Another category named as libraries can be selected to create a new library. Refer Codezy's help for more details about library creation. We will not cover this topic in this training session. Select GOC43 project from templates section. Enter a name for a new project and select location to save project. Here we will create a new folder, Codezy's projects on E drive of computer, and create project with name, My First Project. Click OK to close the dialog. GOC43 project dialog will appear. Select language for main POU in application, which is PLC_PRG. You can select one of the 6 programming languages. We will select ladder diagram. Click OK to create the project. This is Codezy's default view after creating project using GOC43 project template. Once application is created, this device view will be displayed. Do not delete any device, node or objects from device tree. POU, PLC_PRG, is a default PLC program and is mandatory. Do not rename or delete this POU. Let us understand components in the project one by one. On top of device tree there is node with project name. All other nodes are part of project node. Second node is device node. This represents GOC43 main unit in a project. Same device represents all 6 variants of main unit. Project created for one main unit is compatible with all main units. PLC logic and application nodes combines components of control program in main unit. Next node is device tree is GVL. GVL is global variable list. You can define your global variables in the list. To organize global variables, you can add more GVLs in the application. To add GVL, right-click on Application, Node and select Add Object, and select Global Variable List. Implicit I/O list is a GVL containing I/O variables compatible with GOC35 project. Variables from this list can be used while importing GOC35 project in Codezy's v3.5. We will see how to make GOC35 project compatible with GOC43 in another training PPT. Image pool is table of image files used in visualizations in project. To use any image in visualization, first we need to add them in image pool. You can organize images in project by adding multiple image pools. To add additional image pool, right-click on Application Node, and select Add Object, and select Image Pool. Library Manager manages libraries used in project. Necessary libraries are added while creating a new project using GOC43 project template. POU, PLC_PRG, is main POU of control program. All other POUs should be called from this POU. POU PLC_PRG is executed by main task after every 50 milliseconds. Task configuration lists all tasks in the project. As discussed earlier, by default, GOC43 project contains 2 tasks. Main_task is a PLC task and it is executed after every 50 milliseconds. Visu_task is a HMI task and it is executed in the background. If required, you can add one more periodic task to execute another POU from application. Next node is text list. Text list organizes dynamic texts for objects like drop-down list, multi-text display, etc. You can add more text lists in application as per requirement. To add additional text list, right-click on application node, and select Add Object, and select Text List. Visualization Manager and Target Visu. These nodes manages settings related to visualization. Settings like screen size, user management, fonts, start screen, etc. are available. Most of the settings are already done while creating GOC43 project. Refer training program on HMI programming for details. Next node is Home Visualization. This is a first visualization in the project. This visualization is defined as start visualization of project. You can add further visualizations as per application requirement. To add additional visualization, right-click on application node, and select Add Object, and select Visualization. Node keys and LED represents function keys and illuminated keys along with LED on main unit. Keys can be accessed as input and LED can be switched on and off as digital outputs. We will see how to use keys and LED in example program later in this training. I/O extensions represents two I/O extension slots on main unit. You can plug in and configure I/O extension units here. COM extensions represents COM extension slot on main unit. You can plug in and configure serial COM extension units here. You can append and configure communication protocols like Modbus RTU slave or master. Last node in device tree is Ethernet. This represents built-in Ethernet port on main unit. You can append and configure protocols like Modbus TCP client and server to this node. This completes explanation of GOC43 project components. Now we will understand device editor of hardware devices like main unit, I/O extension unit and COM extension units, and also keys and LED. Device editor can be opened by double-clicking device in project tree. Device editor will open as new tab in work window. In device editor, different information of device is arranged in tabs. This is device editor of main unit. We will see contents of each tab one by one. First tab is communication setting. This tab is used to establish communication with controller. We will see how to establish communication with device from PC later in this training. Next tab is hardware configuration. This tab shows easy to use hardware configuration. You can plug in I/O extension units and COM extension unit on main unit. Log tab will show device log showing status and diagnostic messages of main unit in online mode. PLC settings. This tab contains important settings related to I/O updation. Here you can define behavior of outputs when PLC is in stop mode. Keep setting, always update variables to enabled to. Other settings can be kept to default. Parameter configuration. This tab shows configuration of functions of selected module. For example, for main unit it shows configurations for built-in functions like high-speed counter or encoder interface, built-in analog inputs, etc. Backup. Backup tab contains settings related to backup and restore function on GOC 43. You can backup or restore application program and source code to or from SD card. You can also define password for backup and restore function here. Next tab is I/O mapping. In this tab you can see I/O image of selected device. This is main unit. You can find 16 digital inputs and 16 digital outputs here. If you are using main unit with 8 digital inputs and 8 digital outputs, remaining 8 I/O points in I/O mapping remain redundant. That means no hardware I/O will be updated with these I/O points. You can change variable name of I/O point here. We will change name of digital input I00 to start push button and Q00 to lamp. When you want to use this variable in application, open Input Assistance and expand I/O config global mapping GVL. Select I/O variable from list. You can find all I/O variables in list I/O config global mapping. You can use I/O mapping variables directly in application program. No need to declare another variable. IEC objects contains list of IEC objects provided by device. IEC objects are variables used to access or control functionality of the device. You will get variables of HSC counts, analog input count, etc. We will discuss IEC objects in detail in next training. Information contains device information like version number, etc. This is all about device editor of main unit. For I/O extensions and COM extensions you will find only 4 tabs. Parameter configuration, I/O mapping, IEC objects, and information. Few modules like digital I/O extension may not have parameter configuration and IEC object tabs. Now since we have created a project and understood its components, we will write a simple application program to understand application program development. This is problem statement we will use for exercise. We will write PLC ladders such that when user press K1 key on device, red LED of same key should turn on. LED will remain on till key is pressed. At same time, when key is pressed, turn on output connected at Q00. Also add one boolean variable to test functionality without pressing key. That means a parallel contact with key. Show LED status on display using indicator. Before starting to edit PLC ladder, we will first understand keys and LED device. To open device editor, double-click on device. Here you can see keys in input memory %IB2 and LED in output memory %QB2. We can use these I/O variables directly in PLC program to access key and LED. Now we will start editing ladder diagram. We will first open ladder editor by double-click on POU, PLC_PRG. Now at first, we will add contact for key K1 to ladder. We will drag contact element from toolbox to working area. When you start dragging element from toolbox, possible insertion positions will be shown by gray color. Select up arrow to add new rung or ladder network and add contact in new rung. Select down arrow to add new rung after selected position and add new contact in rung. Select start here will place contact on same rung. Contact gets added. Now we will assign K1 key to this contact. To assign variable to contact, we will click on button to open Input Assistance dialog. We will choose variable for K1. Now, we will add coil for red LED of K1 key. Drag coil from toolbox and drop it to working area. Select LED variable from the list. This completes our first task of turning on LED when key is pressed. Now we will add parallel contact for testing key. Drag contact from toolbox and type in variable name, k1_simulate. Press enter. As variable k1_simulate not declared, auto declare dialog will open. Confirm data type is boolean and click OK to close dialog. Note variable is declared in declaration area. Now we will add coil for digital output Q00. Drag coil from toolbox and select output variable. This complete PLC code part of exercise. Now we will design a visualization that is HMI screen. Double-click on Home. This will open Home Screen Editor. Now go to Visualization Toolbox and drag a lamp object from Lamps Switches Bitmaps group and drop it to Working Area. Click on Lamp Object to view properties. First we will set Variable property. Click in the Variable field and then click on the button. It will open Input Assistance dialog. Select Variable from the list. We will select variable for K1 red LED here. Select LED variable and click OK. We will change color of this button to red. For this, change image property to red. This completes simple visualization design. This completes development part of our exercise. Now we will compile the application. To compile application, execute commands build, clean all and then execute build, rebuild all. Message window will show compile messages. Ensure zero errors for the project. Now, we will understand how to establish communication between programming tool and GOC43 main unit and download project. We will first go to Device System menu and set IP address of device. To enter in System menu, press F2 key for 3 seconds. After entering in System menu, navigate to IP setting and set IP address of the device. Ensure that your computer and main unit are in the same network. Connect Ethernet cable between main unit Ethernet port and your computer. Now we will establish connection between CodeZs and GOC43 device. Double-click on Device, GC43, to open Device Editor. Click on Communication Settings tab. Now, you can scan all the GOC43 devices connected in the network. Click on Scan Devices button which will show the list of devices connected in the network. Choose your device from list to establish communication. You will see multiple GOC devices in list if multiple GOC43 devices are connected in the network. You can click on Wink button so that LCD backlight turned off momentarily on the selected device. This will help in identifying correct target device for download. Click OK to close the dialog. Once you are connected to the device, execute online logging command to initiate download. If target device application is different than one in CodeZ's project, the download application message is displayed. Click Yes to continue with download. Progress of download is displayed on status bar. During download, device shows first screen of system menu showing status of CPU as memory error. Once download is complete, controller shows stop mode on status bar. This means download is complete and you can put controller in run mode. Now execute command online, run to put GOC43 in run mode. You can also use run command on toolbar. Now status of controller is displayed as run mode in status bar. Device shows user screen. You should be able to see lamp showing of status on device screen. Now we will test application. Press K1 key and confirm that red LED on the key turns on. Also lamp on screen is now showing red color. Releasing key will turn off LED and also lamp on screen will change back to normal state. Let's see debug features in Codesys. Once you complete download of project and you are online, you can see status of variables in working area on the contact or call. You can see status of variables in declaration window also. Flow of execution is also indicated on ladder diagram. Watch windows can be used to monitor variables. To add variable to watch window, right-click on variable in working window and select option Add Watch. Different monitoring variables can be managed in 4 different watch windows. Use command View Watch in View menu. To remove variable from watch window, simply select variable and delete. Now we will learn writing and forcing variable value from Codesys. Writing variable means value will be written to variable only once when write command is executed, whereas forcing will keep values forced till force is released or PLC power is recycled. To write or force variable, click in prepared value column in declaration window and execute re-values or force values command from debug menu. Prepared value can also entered by double-click on the variable in working window. Force can be released of individual variable or all forces can be released at once. Use unforce values in debug menu to release force. Now we will learn source code download in GOC43. When we download application program to GOC43, only compiled binary code of application gets downloaded to device. You cannot upload application from controller back to Codesys. To be able to upload the project, you should download source code to GOC43. This concept is same as GOC35. Source code will contain all comments and variable names in project along with all application data including images in HMI application and user management data in project. Execute command source download to connected devices to download source code. Download progress is displayed on status bar. That's all about introduction to Codesys. Thank you. Share your valuable feedback on GOC training feedback@asia.meap.com. Also watch other videos in GOC43 training series. Next training video. Ladder editing for GOC43.